Nonlinear systems. Nonlinear systems are systems that are not straight lines or not flat planes. Everything we've done up to this point has been, slope-intercept form lines. You did a 2x3 matrix and you could solve that. Or it was a 3x4 matrix, and those equations were actually flat planes, is what they actually make in the three-dimensional space. Nonlinear systems, we're going to deal with things that make curves like parabolas, maybe mixed with a linear one, or maybe it's two parabolas that we're going to deal with, and we're going to find out, what are the solutions to that system. So let's start with just maybe a little more straightforward one. 3x minus 4y or minus y is equal to -2. And then the second equation in the system is 2x squared minus y is equal to 0. And we want to solve that system of equations. And the key, recognizing that it's not a linear system, because they're not going to, on the final exam, they're going to say, solve the system. And they don't want to tell you, solve the nonlinear system. They're going to say, solve the system. So what makes this nonlinear? The x squared, exponent on one of the variables, or sometimes both of the variables. We'll see some of that in just a moment. So we see an equation that's linear, and then we have one that's quadratic there. So there's some things that we can do to solve these. What are some methods before we learned about matrices that you use to solve linear systems of equations? Maybe in Algebra 1. Substitution, that's a great method. Elimination was the other one. Both of those Algebra 1 concepts, but not with nonlinear stuff. You have linear things then. Substitution is usually a really good one to use, especially when you have two equations that don't match up. Like here, we don't have x squareds in both of them, or y squareds in both of them. We have one that's got just plain x's and plain y's, and one that's got an x squared and a plain y. So I look at that and I say, okay, well, maybe substitution might be the best thing to do. So what I would think about doing is maybe solving one of these for a variable. And I'm thinking, well, I'm fairly used to solving the top one for y, right? So I'm going to do that because I'm used to doing that. So to solve that for y, we'd have negative y is equal to negative 3x minus 2. Divide everybody by negative 1. And that gets us y equals 3x plus 2. What can I do with that? Yeah, take that and replace or substitute for y in the second equation. So that now that equation is 2x squared minus 3x plus 2 equal to 0, which is an equation that only has one variable in it instead of two, which is doable. We can solve one variable equations. So I'm going to distribute the negative sign. And then we've got a quadratic equation. So if it's quadratic, we need it to be equal to what before we can solve it? 0. This one is already, so not a whole lot of work to do there. What are our options? Factoring is a great option. Works really good on this one. What's another option if it doesn't factor? Quadratic formula is another great option. So we have those tools to solve a quadratic. We're going to use them. I think factoring is my favorite way of solving them, if it will. So that's what I'm going to do here. So multiply to be -4, add to be -3, -4 and 1. Is that right? Sounds right. Yeah. -4, 2 times -2 gets me -4 up top, and then the b in the middle. And then, so I can't do shortcut on that. And group from there. So been a little bit since we've solved a quadratic, probably a couple of chapters ago. Well, we did a little bit in logarithms in chapter 6, but not much. So 2x, x minus 2, and then 1. So here we have 2x plus 1 and x minus 2 are factors. So set those factors equal to 0. And we get two solutions there. We get x is -1/2 and x is 2. Okay, well, when we're solving systems of equations, the answers are in ordered pair forms, or if it's 3 variables, in ordered triple form, 4 variables, ordered quadruples. But here we got 2 x values. We need y values to go with it. Where can we go to get those? Right to the original problems, or one that we've worked with and gotten y by itself, maybe. Doesn't matter which one you go back to. Excuse me, go back to. I try to go back to the easiest one. Same way I would in a linear system. I'm going to go back to this one right here. There I've got y equals 3x plus 2. I'm fairly certain I didn't make any mistakes getting there. And because it factored, and usually they're going to, and that's nice. So what I'm going to do is I'm going to plug in and get the y value that goes with that. It'll be negative 3 over 2 plus 4 over 2 positive 1/2. So one of our solutions, put them right here in the middle of the page, would be negative 1/2 positive 1/2. And then I'd work out, well, what happens when x is 2? That's 6 plus 2. That'd be 8. So the other solution would be 2, 8. All right. So that's using algebra to solve a nonlinear system. Let's look at graphing as an option. Okay. I'll kind of give you a second here. I'll let my calculator be open. You guys get that copied down. Okay. So using algebra, definitely a stronger method than graphing is going to be, but I want to show you that graphing can be used to kind of help you get an idea of where the answers are even at, so that you can tell if you're right or not. Which is, we always want to know if we're right or not. At school seems to be the only time I am. Not much right anywhere else. So I've already solved that first equation for y. So I could go ahead and type in 3x plus 2 as that equation. But I don't have the second equation from the originals. I need to get y by itself on it. So I'm going to do that. Maybe here on the side, I know I'm going to subtract 2x squared over there and then divide by negative 2. So that'd be y is equal to positive 2x squared. So that's what I would type in as y2. Then I'm going to graph those. So there's my straight line. That's the first equation. And here comes my parabola. And that crosses in how many places? 2. I got 2 solutions. So that seems to be leaning in my favor. It looks like I've done something right. Where does it look like this one's at? Like a negative 1/2 and positive 1/2 y value. How can we check that? Trace would be one way. Yeah. If I could hit trace and type in negative 1/2. And yeah, right there, where they're at. And then over here, there's positive 2 way up here toward the top. It's 10 at the top, so it looks like it's about 8. Looks like the right spot. So I'm gonna trace it positive 2. And right there they are. And here's a neat thing with your calculator. Notice right now it's giving me the blue equation. It's saying this is the ordered pair. If I press the up arrow key, it'll swap to the second equation. And it's a little bit off, but not quite. Not enough. It's a rounding error is basically what we're seeing there. Is when I swap that. If I hit 2 again, I bet it ends up, back on 8. When you press that up arrow key, it kind of adjusts the spider just a little bit. But you can trace it again on the red one. You don't have the color one. It's going to say Y2 up there at the top. Y1, Y2. You just got to remember which one you're dealing with there, and you can trace on either one of them. You should see the same ordered pair for where they're crossing. Where they cross is the solutions. Okay, so graphing is an option. It's really a good option when they cross at decent places. Like this one's not too bad. The negative 1/2, positive 1/2 is not great. But I'm better at estimating 1/2 than I am square roots of 3, right? So the graphing is a good option, but not always the best option. Algebraically, I always think is a better option because you can get the exact answer, but you can get a really good idea if you're close on the graphs. So getting y by itself is going to be key on the graph. So we're going to look at that with every problem we do today, or most every problem we do today. Probably not every problem. All right, let's look at this one. X squared plus y squared is equal to 13. X squared minus y squared equals 7. I don't know that anybody would know what the equation on the bottom makes, but does anybody know what shape the equation on the top makes? Sir, we're doing that.
I just guess. I'm naturally that smart.
Oh, okay.
I'm just kidding.
Should have been something you saw in maybe geometry. Been a while since you've seen that. The equations of circles are in geometry. That one would be a circle that's centered about the origin with a radius of the square root of 13. If you remember that from geometry class. It's not necessary that you know that, but it does kind of help you get an idea of what the graph's going to end up looking like eventually when we look at it. Because it's x squared plus y squared, that tells me, oh, this is going to be a circle.
So the bottom
And it's because it's got a minus sign. It makes it a hyperbola, which you probably have not seen. Because that's conic sections, and that's something that we talk about in pre-calc. Like I said, it's not a necessity that you know what that shape is. A hyperbola is kind of like what? Erase that away. A hyperbola is kind of like a parabola, but one on top and one at the bottom.
Do they connect usually?
Ms. Ross showed you that in geometry. Yeah, you may have seen this in geometry. That shape is what's happening there. But that's a hyperbola is what that shape is. And then,
Do they usually connect?
no, they don't usually. They will not connect in the middle. There's a space in between there. And depending on the numbers that are in the problem, how much space is there and how skinny, how wide they are.
It does connect.
Probably two different parabolas is what I would say. Because the hyperbola is never going to connect in the middle there. Out of that. So I'll lay my pen down. Okay. All right. Now, so let's think algebraically first, and then we'll look at the graphs. Graphs are a little bit more difficult on this one because you got y squared in there, and it's hard to get y by itself. It's y squared. So thinking about this algebraically, thinking algebra 1 skills. We did substitution on the last one.
Elimination.
Elimination would be good on this one. Why? You got a y. Yeah, y's are opposite. You got a positive y squared and a negative y squared. So if you add these two equations together, the y squared is going to cancel out. You get 2x squared is equal to 20, right? And then that's a fairly easy problem to solve, right? How do you solve it? Divide everybody by 2. That's good. So that's x squared is equal to 10. And then what? Square root. But if we take the square root of 10, what do we have to remember? Plus or minus. It's got to be plus or minus the square root of 10. So we got 2 answers for x. So that means we should be getting a couple answers for y, right? All right. Well, let's go back and get those answers for y. So we're going to pick one of the equations to start with. I'm going to pick the top one because it's got all positive signs in it. I don't have to deal with the negative. Not that it matters. Just pick the one you think is the easiest. I think that's easier. So when I plug that in, I'm going to do, okay, when x is positive square root of 10, that would be square root of 10 squared plus y squared equals 13. What happens when you square the square root of 10? It gets rid of the square root, so that's 10 plus y squared is equal to 13. And what's that give you? Y squared is equal to 3. So y is equal to plus minus square root of 3. So for that one x value, we got 2 different y values. Okay? So when we go to write our solutions, so I'm going to make a list over here. I got square root of 10, and then positive square root of 3, And then I got another ordered pair, square root of 10, negative square root of 3. Okay, so that's just from one x value. We got two different y values. That makes sense because, we got two x answers because we had an x squared. And then when we plugged it back in, we had y squared. So that should get us two answers for y as well. So that means we're going to get four answers.
So do we have to do the U thing,
What do you mean?
like,
No.
where you have to write a certain
he's talking
way?
about-
No, you're talking about domain. No, we're not doing that. These are ordered pairs that we're finding here, not intervals. So ordered pairs. It's positive right now.
So you have two answers that are positive and
They're both
two.
positive.
They're both positive square roots of 10. The square root of 3 is the plus or minus on that. Now we're going to work with x being the negative square root of 10.
And you plug it in the
I plugged it into the same problem. Again, it doesn't matter which one you plug it into. Just plug it into one of them and get some answers. So when you square the negative square root of 10, that's 10 again. No, it's not negative 10. Negative times negative is a positive. Because squaring negative square root of 10 means negative square root of 10 times negative square root of 10, which is positive. It ends up being the same answer. So it won't always end up being the same answers. It just happens to on this one. Yes, you're still going to write them because it's a different x value this time. The x value is negative square root of 10 this time. So we're getting y squared is equal to 3, and then there's y is equal to plus or minus the square root of 3 again. So the ordered pairs that go with the negative square root of 10 are positive square root of 3 and negative square root of 3. There are 4 places that this stuff is going to cross. Now, here's where graphing kind of, where's the square root of 10 at? It's a little bit past 3. And square root of 9 is 3, right? So 10's got to be a little bit past 3, right? So it's a little bit past 3. Where's the square root of 3 at? A little past 1, closer to 2 than it is to 1 probably because it's closer to 4. So we can estimate that where the decimals would be for that. Yes, sir. Where at?
Did you rewrite the square root of 10?
I plugged in negative square root of 10 from my x answers into the first problem and solved it. And I ended up getting plus or minus square root of 3 again. So I have ordered pairs. When I first solved the positive square root of 10 for x, I got this ordered pair and this ordered pair. Then this part is where I plugged in negative square root of 10, and I got these two ordered pairs.
Because plug in the square root of 3.
We didn't get that first. We got the x values first. So that's why I'm plugging those in. Yeah. What I find first, what I'm using.
Will your solutions always be both the positive and the negative and then switch?
If you took a square root to solve,
Because like that one, one says positive, one says negative, and then you switch to 3.
because I use square roots to solve on both variables. If you don't use square roots to get x, then you probably won't have both of them. If you don't have to use a square root to get y, you probably won't have both of them. So this one, you use square roots on both of them, so you got plus or minus on both of them. Is the reason it's got a plus. If I wanted to check this with graphing, one thing that I've got to do is I've got to look at these equations and get y by itself, which is not easy, or not as nice as it was on the first example. Because to get this one with y by itself, I subtract x squared, and that gives me y squared equals negative x squared plus 13. But to get y by itself, what do I have to do? I have to take a square root of all that. So that would be y equals plus or minus the square root of negative x squared plus 13. What did Katie tell us this was a picture of? A circle. So when we graph this, we got to have the positive side and the negative side to make the circle. So I'll go ahead and go to the calculator and clear out the first example. And on y1, I've got to put the positive side of that. So positive square root of negative x squared plus 13. Or if you did 13 minus x squared, it's the same thing. But then on y2, I've got to do the negative side of that. And then I'm just going to let you see that graph there. It doesn't quite look like a circle, but the resolution on the plane is it's wider than it is tall. If I hit zoom 5, it adjusts it. Now it looks more like a circle. It leaves this gap right here because the resolution gets to, it's not fine enough to be able to draw that curve because it's not a whole lot of stuff there. I don't know. You can do it this way, but I can't do it that way for some reason. But these do connect. Okay, so that's the circle for y for the first equation. So we need to get the second equation to be y by itself. Well,
I think the graph for the red part, I typed it in and just
make sure that the
some kind of error note that only 3 can be typed in and graphed.
bring it here. Let me see.
I got some really good bottom like I don't think you didn't put the negative sign. That's what I'm saying. I put it on.
Yeah, put it on the. Well, it should be on the inside and on the outside. Yeah, I don't understand. It just cuts off the system, doesn't it? Let's try it. I don't know what it was doing, but I cleared all the memory and I don't know. Yeah. All right. All right. So we've got the circle part done. So we need to do the hyperbola part. So that was x squared minus y squared is equal to 7. So let's get y by itself on that. So minus x squared negative y squared is equal to negative x squared plus 7. Divide by negative 1. And then take the square root, plus or minus. So we get y is equal to the positive and the negative square root of x squared minus 7. Okay, so when you go to graph that, you got to graph the positive side and the negative side.
So it would be handy to have color calculator.
It is, but it's not necessary. If you need to look at individual pieces, it is, but we're looking for where they're crossing. So it really doesn't benefit you any. It's good for teaching wise because I can tell you, okay, this is the positive side, this is the negative side, but you're just looking for the picture. The big picture is what we need at the end. So negative or positive and negative side of the square root of x squared minus 7, and then negative square root x squared minus 7 graph. So there's the positive side. It's gonna turn to the side, and it's almost a baseball. This again, the resolution here gets too fine for it to be able to draw that curve in there. But we see it crossing at 4 places. And if we traced at square root of 10, oops, second square root of 10, there's, we can see it's hitting right there where it's crossing. So we can see the graph. So we get a circle and a hyperbola. This, it's the equation turned it sideways by the numbers that were done there, depending on which one's negative, y or x is the way it goes. So we see a graph can help us see where our solutions would be. I think algebraically for this one was easier. You can do quite a bit of work to get y by itself on each problem. So that can be an issue. Okay. All right, let's look at this one. To that. All right, let's look at a fun one to end today with. All right, 3xy minus 2y squared equals negative 2. And then 9x squared plus 4x, or 4y squared, sorry, equals positive 10. All right, so this one's got an xy term in it. It's not the greatest of things.
Question. The bottom will be a circle or no?
No, because it's got different numbers in front of it. Well, if both numbers were the same, it'd be a circle. This one is an ellipse, like a football shape kind of. Oval. Yeah, oval would be a good way to describe an ellipse.
Can you cancel out the Y's on that one too?
Yeah, that's a good idea, Jay. How do I do that? That's exactly what I'm going to do. I'm going to cancel out y's because I got opposites there, right? And that's the matching.
9x plus 2y.
All right, yeah, I got to multiply everything on top by 2 before I can do anything. So I can get the opposites on the y's. So I'm going to double the top. So that gets me 6xy minus 4y squared equals negative 4. And then the bottom one's not changing. So we multiplied row 1 by 2 and then change row 1. That's what we were doing. If you want to relate that to matrix operation. To get these guys to match or be opposites. Because now when I add the two equations together, the y squareds go away.
So if you do whatever multiply by 2, you don't have to do both.
No, you don't have to do both. You can do one and not the other. Whatever you need to do to get opposites to happen. If you need to multiply 1 by 7 and 1 by 3, you can. It's legal to do that. Okay. Now, here's the thing that makes this a little bit more difficult, actually a lot more difficult, is the fact that it's got this term that's x times y. So we don't have a problem that only has x's in it now that would be easy to solve. We have a problem that has x's and y's in it still. But what we can do is we can take this problem and maybe get y by itself.
Wait, can we do what Thomas said? Factor out an x?
But that's still gonna leave an x in the parentheses. If what you're saying is if you factor out an x, I still have 9x plus 6y. I still got an x and a y tied together. It's not 0 because it's not like terms with the 6.
So what's your way?
Is, all right, so this is what I would do. Everybody's divisible by 3, so I'm going to divide by 3 first. Just to make it smaller numbers. Smaller numbers are usually easier. So that's 3x squared plus 6 or plus 2xy equals 2. Now I'm going to get y by itself, so I'm going to move stuff that doesn't have a y. This 3x squared doesn't have a y, so I'm going to subtract it. So it leaves me 2xy is equal to 2 minus 3x squared. Now, I want to leave y on that side. So I'm going to divide by 2x. Yeah. And I'm just going to leave it like that, 2 minus 3x squared over 2x. Now, what's the stipulation that I have to make here about x? That x cannot be what? 0. Because I got a 0 in the denominator. If x ends up being 0, then I can't do that. If it's one of the solutions where is x is 0, then I can't do that. I don't think it is. That would end up being what's happening. If I solve it and get x equals 0. That doesn't happen. So, yeah. All right, so now we have something that is y. So that means I should be able to replace y in one of the problems. I'm going to go to one that I think is a little easier, and that would be the second one.
That's ugly though. Plug that y.
Yeah, it's not pretty, but it's just algebra. All right, so I'd have 9x squared plus 4 times 2 minus 3x squared over 2x squared equals 10. So I'm going to the second equation, and I plugged in the y that I found down here for y. That means I got to square that. All right. So the bottom part's easy. I'll do that part. Y'all do the top. So 2x times 2x is 4x squared. I got it. I do that part. That's the hard part, dude. It's the denominator of a fraction. That's what makes it hard. No, the top part. If you square 2 minus 3x squared, negative 3x squared times negative 3x squared is 9x to the 4th. And then we got a plus 4. In the middle, we got 12x squared. It's just squaring a binomial, guys. That's what it is. You square the front piece. That's the plus 4. Square that. That's the 9x to the 4th. Multiply them together. That's 6x squared. Double it. 12. Not yet. Now we got to multiply everything by 4. But the good thing is this 4 on the bottom and that 4 right there just cancel each other out. Yeah. Now, rational equations. Rational equations are, you got to have the same denominator on everybody. So what's the denominator of the fraction that's in here? X squared. So I need to make the 9x squared have a denominator of x squared. So I'm going to multiply by x squared on top and bottom. I'm going to do the same thing over here. So I get everybody to have the same denominator. So that's going to be 9x to the 4th, 9x to the 4th, minus 12x squared, plus 4 is equal to 10x squared. And then all of that's over x squared. No, because they're both positive. They don't cancel each other. They add together as like terms. 18x to the 4th minus 12x squared plus 4 equal to 10x squared. Now I'm going to drop the denominator here because they're the same. And when you're doing rational equations, you can drop, once you get the denominators the same, all you're worried about is the numerator. Now, this is something to the 4th power, so I need to get it equal to what to solve it? 0. So I'm going to subtract 10x squared. So that's 18x to the 4th minus 22x squared plus 4 is equal to 0. We're here till 10, guys.
What you do with the X?
In the bottom, you drop it off because they're all going to have the same denominator, so the numerators have to be equal to each other. That's what's happening. We know x can't be 0 already, and that's what the denominator does anyway. Okay, now that's a 4th power problem. We solved those a while back, so we should know how to do that. I see that they're all divisible by 2, so I'm going to do that. So that's 9x to the 4th minus 11x squared plus 2 equals 0. And then I know I'm seeing that as a trinomial, so I'm thinking I can factor that. Multiply to be 18, add to be negative 11, to be negative 9 and negative 2. 9 times 2. So 9x to the 4th minus 9x squared minus 2x squared plus 2. Group that, so that'd be 9x squared, parentheses, x squared minus 1 minus 2, x squared minus 1. And keep factoring, so that's 9x squared minus 2. And then x squared minus 1. What do we know about x squared minus 1? That's right, it's x plus 1 and x minus 1. Now we can solve and get x's. Once we get x's, we've got an equation over there on the right, up there, that we can get y's with real easy. That right there. Once we get x, we can get y's. We got to get all these x's. There should be how many of them? 1, 2, 3, 4. This is x squared. 4. Should be 4 x's that we get here. So we're setting those equal to 0. So 9x squared minus 2 equals 0. X plus 1 equals 0. X minus 1 equals 0. I'll do these over here. Y'all do the hard one.
Yeah.
It's still algebra, guys. It's not anything new. Right. Then you take the square root. All right, so square root of 9 is 3. Right? When I take the square root of a fraction, I take the square root of the top, the square root of the bottom. And the bottom just happens to simplify on this one. So we have 4 x values. So that means we need to find 4 y values that go with those 4. Okay. All right, so we're going to use this problem. That y is equal to this stuff to get our y values, because that's already got y by itself. So I'm just going to plug them in there. Notice that none of our answers were x equals 0. Right? So that means that was okay for us to do that. So I'm going to, y is equal to 2 minus 3x squared over 2x. And I'm going to plug in. I've got x equals positive 1, x equals negative 1, x equals square root of 2 over 3, and then x equals negative square root of 2 over 3. Those are the 4 x values that I found. If you want to get y by itself on them, you could. That's not real easy, especially considering the first equation has the xy term. That makes it really a lot more difficult to graph. Again, graphing isn't a good option, but it's not the easiest option all the time. This has been pretty tough algebra, but it's not it's still just as tough algebra to graph it, honestly. So y equals 2 minus 3 times 1 squared over 2 times 1. And work that out. So that'd be 2 minus 3 is negative 1, negative 1/2. So we get this ordered pair, 1, negative 1/2. That's one of our solutions. And then do negative 1. Squared, so that'd be negative 1 over negative 2, which would be positive 1/2. So negative 1, positive 1/2. And plug in positive square root of 2 over 3. Not as nice on these here because you got the square root of 2 in there. So it'd be 2 minus 2 over 3 over 2 square root of 2 over 3. Possible. And then 2 minus 2/3 would be 1 1/3, which would be 3/4 over 3, divided by 2 radical 2 over 3, which is the same thing as 4 over 3, times 3 over 2 radical 2. It would be 2 over square root of 2. So the ordered pair would be square root of 2 over 3, 2 over square root of 2. And then I'm gonna go down here and do the other one.
And this is all C, right?
This is all that example, yeah. Two over radical 2, that is correct. Which is 2 minus square root of 2, or 2 over 3 again. So same numerator, but a negative denominator. So that just means it's going to be the negative 2 over square root of 2, because everything else is the same. Just changing the sign. So the ordered pair that goes with that would be negative square root of 2 over 3, negative 2 over radical 2. Won't be many of these. Be more like A and B. Gonna take some practice, no question. To be able to do these, look for the substitution elimination first. That's always, the easier thing to happen. That's going to happen most of the time. You're going to have very few that you got to do something this extensive with. But I didn't want to turn you loose into the problems, and you end up with when it's got it's going to be a tough one when it has the XY term in it. That's when you know it's hard. Problems that you want to look at are on page 910, 5 through 54. If you look at those, that should get you ready for Monday. Yeah, you got work day tomorrow, and then the weekend to make sure you know how to do it. No, they told us not to let you guys be running around. They got testing going on. They told us not to let you run around.
Oh, dang.
That far enough?